Hey everyone, welcome back to the channel. Today we have an exciting topic to discuss that will make your software development workflow a whole lot easier. We're going to dive into the world of Commitizen, a tool designed to streamline your commit process and improve collaboration within your development team. Whether you're a junior or mid-level software engineer, this is definitely a tool you'll want to know about. So let's get started. Before we jump into the nitty-gritty details, let's start with a quick overview of Commitizen. In software development, version control systems like Git are essential for managing code changes. But sometimes writing commit messages that adhere to a consistent style and format can be challenging, especially when you're working in a team. That's where Commitizen comes in. Commitizen is a command line tool that provides a simple and standardized way to create commit messages. It enforces commit message conventions and helps you maintain a clean and organized commit history. It integrates with popular version control systems like Git, making it a valuable tool for any software engineer. Oh, and it can help you generate a changelog too. The first step is to install Commitizen. I'm going to use Homebrew for this, so I'm going to type brew install Commitizen. But if you don't have Homebrew or prefer not to use it, you can also use npm, and there's a couple other package managers as well. Now that we've installed Commitizen, we can go ahead and make a new project. This one's going to be in Go, but you can use any language you want. I'll go ahead and initialize a new Git repository in this project, and since it's Go, I'm going to use modules, and we'll say go mod init and then the project. Great, we've created a new module and a new Git repo. I'm going to go ahead and touch main.go to create that file, and it seems like a good spot to go ahead and commit. We see that we have a go mod file and a main.go. But first, let's use cz init to initialize Commitizen for our project. We can choose what config file we want. We're just going to choose the toml file. You can choose a different one if you'd prefer. I like working with toml, so we'll just use toml. Now we'll choose a commit rule. Conventional commits is probably the most popular, but you can customize your own or use one specifically made for Jira. There's also other plugins that you can install to give you more commit rules. For now, let's just use conventional commits. Great. Now we choose the source file for our version. This is a little confusing, but if you're using a tool like Rust or PHP, which has cargo files or composer files respectively, you can infer the version from the version number mentioned in that file. Another example of this is npm, poetry files for PyProject, pep621. You have a lot of options. Go is an interesting one where we don't have an option, so I'm just going to use Commitizen to manage that version. The other option that we haven't mentioned yet is at the bottom. SCM allows you to fetch the version from Git, and it doesn't need to set the version back, which is kind of nice. For now, let's just use Commitizen. We'll keep this simple. It couldn't find an existing tag. That's because this is a brand new project, so it set the tag to version 001. We can change the correct version format if we want, but version itself is it's fine for what we're trying to do. So we'll leave it. We can choose a version type. I'm going to choose semantic versioning. And we can choose to create the changelog automatically on bump, and I'm going to say yes. We can keep the major version 0 during breaking changes. It defaults to yes. I'm fine with that. We can go ahead and say yes. Now it'll ask us what type of pre-commit hooks we want to install. I'm going to pass on any of these, but if you want to lint your commit messages, this is a great opportunity to do that as well. And now you can see that we have a new command called czbump. And it tells us that we can bump the version by running czbump. So let's get status and see if anything's been created. Great, we have that new cztoml file. Let's go ahead and add everything in our project. And now we can use czcommit. You can see that there's a lot of different options like fix, features, docs, styles, refactors, performance, test, build, continuous integration. A lot of different options to choose from, and you want to choose the one that makes the most sense for what you're committing. For our sake, I'm just going to put CI. You could argue that this might be build as well, but since we're just really trying to get the project up on GitHub, this seems like a good first start. Now it's going to ask what the scope of the change is. In our case, it's the repository. It's not a class or a file name. And we can give an imperative summary like establish repository for Go project. I actually probably shouldn't put that much information in there because there's a section for contextual information about the code changes, and that is a great place for more information. So your short imperative summary should be short, but your contextual information can be quite long, if you'd like it to. It's going to ask if this is a breaking change. We're going to say no. Now we have a section for the footer. I'm going to say closes number 1. And if we push this to GitHub, it's going to link our number 1 issue. So issue number 1 in our commit message. And whenever this gets merged, we can actually have that automatically close our issue for us, which is really nice. Great. So we can see that it made some insertions, and now we can run cz changelog, which will generate a changelog. Yep, there it is. And if we cat that, we can see, hey, it's unreleased. Well, why is that? Let's go ahead and try to bump. So we'll use cz bump, and we will see if we can bump our version. That should generate a changelog, right? We told our cz init to generate a changelog when we bump, so this should generate a changelog. We see that tag 001 could not be found. That's fine. We saw that error message earlier. We know that we're going to start with 001. It asks if this is the first tag created. We say yes. It tries to bump the version, but it says no commits to bump. These commits are not eligible to be bumped, so let's go ahead and make one that is. I'm going to fire up my editor of choice and open main.go. From here, I'm just going to write a really basic Go program. You don't need to know Go to understand how this works, but if you program much at all, I'm sure you'll be fine figuring it out. We'll declare a package called main. We'll go ahead and import fmt or fumpt. We'll define a function for our main function. And this main function is simply going to say fumpt.println, and oops, the P needs to be capitalized. And we'll pass in the string hello world, a classic program. Great, now we can see that we have our modified main.go file and we have an untracked changelog. I'm going to go ahead and add both of these. I would like to publish the changelog with my repository, so let's do that. Now I can run cz commit, and this time we actually have a feature, so let's select feature. The scope of this change would be main.go, and a short summary would be say hello world. We can add more contextual information. This is maybe a little excessive, but let's say creates a dependency on the fumpt package from standard library. Is this a breaking change? No. And our footer, let's say it closes number 2, keeping those issue links going. It'll make this commit for us. And now if we get status, we see that there is nothing on the branch to be committed. Now if we cz bump, we'll see the same thing before, but it detects a minor increment. There it is, bump version 001 to 010. And now if we ls, we can see our changelog, our go mod, and our main.go, and get status has a clean branch. Let's take a look at that changelog. Great, we can see that in 010, we added a new feature called say hello world, and that's in main.go. Now if we look at our git log, we can see that there's not only the same information in our git log, but there's that contextual additional information that may not be useful in a changelog, but it might be useful in our code repository history. Again, though, if it is useful in your changelog, you can change the format that the generated changelog messages use. So you could include that contextual information if you'd like, but for our sake, we'll just keep it with the bare minimum. Commitizen's benefits go beyond individual developers. It greatly improves collaboration within development teams, especially when multiple people are working on the same project. When using Commitizen, everyone on the team follows the same commit message format, which leads to a more organized and understandable commit history. This consistency makes it easier to track changes, identify the purpose of specific commits, and as we even saw, automate release notes or changelogs. Additionally, Commitizen integrates well with other tools commonly used in the software development workflows. For example, it seamlessly works with GitHooks, continuous integration systems, and even code review tools like GitHub or GitLab. There you have it. Commitizen is an excellent tool for simplifying the commit process and ensuring consistent commit message formats. By using it, you'll not only make your life easier, but also enhance collaboration within your development team. Remember, as a software engineer, mastering tools like Commitizen will help you become more efficient and effective. So give it a try in your next project and experience the benefits firsthand. That's all for today's video. If you found this information useful, be sure to give me a thumbs up and subscribe to the channel for more software development tips and tricks. As always, happy coding.